Buenas tardes, bienvenidos al seminario de este viernes. Es un seminario sobre hacer que nuestra ciencia sea relevante para la política y la práctica en un mundo difícil y acelerado. Tenemos el gusto de tener con nosotros a la doctora Sussane Moser, quien es geógrafa, obtuvo el grado en la Universidad de Clark en Massachusetts en 1997. Ella trabaja como consultor y académico independiente a nivel nacional en Estados Unidos, así como a nivel internacional desde el oeste de Massachusetts. También es investigadora del Departamento de Estudios Ambientales de la Universidad de Antioch en Nueva Inglaterra y académica asociada del Departamento de Arquitectura del Paisaje y Planeación Regional en la Universidad de Massachusetts-Amherst. Su trabajo con agencias gubernamentales, organizaciones de la sociedad civil que trabajan con fines no lucrativos, fundaciones, así como otros investigadores y consultores, se centra en la adaptación del cambio climático, interacciones entre ciencia y política, comunicación efectiva sobre cambio climático y resiliencia psicosocial para enfrentar retos traumáticos y transformativos asociados con cambio climático. La doctora Moser es editora de 2 volúmenes que han sido premiados, uno sobre adaptación exitosa al cambio climático y otro sobre cómo comunicar el cambio climático. Es una escritora prolífica, oradora muy inspiradora, ha formado parte de consejos consultivos de Future Earth, del International Science Council, de la National Research Council en Estados Unidos y ha contribuido con el IPCC y en la Evaluación Climática Nacional de Estados Unidos. Por lo cual para nosotros es un honor tenerla como parte de esta serie de seminarios, and we're very thankful to have you, Susie, with us. Thank you very much, and we're able to start. Thanks.
Thank you so much for the kind introduction, and thank you all for being here and for tolerating a presentation in English. I would not be able to do this in Spanish, so I really, really appreciate you doing the hard work of translating in your heads as I go. So what I want to do this afternoon in this presentation is to help us to just hang on a second. I got a message popping up here. Show my screen. I am already showing my screen. Are you seeing it? Maybe I should check with you first before I get started.
Yes, we're seeing you and your presentation.
Wonderful. Okay, great. So what I would love for us to do, as you heard in the introduction of my background, I'm not an ecologist, but I am a scientist that thinks a lot about how our science can become relevant to policy and practice, to society at large. And I think there is a big question that arises, and that is how we do that in a world that is ever faster and contradictory and antagonistic in many ways between the different parties and different sides on any issue. How do we navigate that kind of a world with our science? How can we stay relevant or become relevant for the first time? So what I would like to do, and I hope you can sort of just sit back for a bit for this hour and just reflect on that with me. It's not like I have this all figured out. I think it is something that we need to really think about hard together. So what I would like to do is sort of do this in 4 parts. First of all, I want to think a little bit out loud with you about what does it mean for science to be useful or to be used? For what end? How do we use science at all? What do we know about that? And then think about sort of this acceleration in the world and how science can be relevant. What do we know about that process? And what difficult paradox does that set up for us? And then I want to spend a little bit of time in terms of just the communication, because I believe there is a big challenge with the communication of science per se that we need to really think about and understand from the psychological end of things, so that it's not only heard but actually can be used. And then the last bit will just be open for your questions. So as we go along, if you have any questions, please put them in the chat. And then in the Q&A, you can also raise any overarching or other questions verbally. So we'll call on you then. So let's start with this first piece. What do we know about use and usefulness of science? I guess the first question we have to ask ourselves is, how might we be of use, right? Sometimes we think, well, if we just provide sort of a state of the knowledge of, and send that to a journal or send that to a policymaker, then, you know, that's one important thing that we want to, or one important way in which we can be useful. Another one might be a goal that you have in your own work, is to simply foster greater understanding of whatever the topic is that you're focused on, but also of science as a process, science as an institution and activity of society. And so, you know, maybe your goal is just that, and that's perfectly fine as well. Maybe you would actually love to improve the relationship between yourself and your colleagues who produce the knowledge and people who might use it. And of course, the question arises, who is a knowledge producer? Is it only science, or is there a broader set of actors that we might put into that category? You might think of people who hold traditional ecological knowledge, indigenous knowledge. Are they not also knowledge producers? And so then you become maybe the user in that kind of conversation, right? So it is really about building relationships and improving those and that in and of itself is a useful outcome. And then of course there is the direct use of information, scientific information, in, say, decision-making, in planning, and ultimately maybe what motivates you to even be here at this meeting, at this webinar, is how can we support better decision-making and ultimately better outcomes in the world. And all of that, of course, is something that you as a scientist might be interested in, you know, to have these practical and political or policy relevant outcomes. And yet you also are a scientist and you want to keep doing interesting science. So there might be some trade-offs or at least some negotiation of that particular balance to strike. Well, so that might be what you intend. What do we know about how science is used? So interesting, you know, those of us who work and study the use of science and how to make it actionable or usable or any of these other words that are being used, we actually have not very often asked the question in a very sincere way, well, how is the science used? In my own work, I've come across a number of different uses. One is this practical one that, you know, you literally provide input into a decision, you inform planning, maybe how standards are set, or, you know, when someone might cross a threshold, or you provide quantities that are needed to calculate, you know, when you might go to a different direction with your decision. Maybe it's also to just simply help setting a research agenda, right? We often do this in, if you think about IPCC or other assessments, IPBES, you know, it's both to be useful to a policymaker, but it's also very important for the research community itself, that it might then see, oh, here are the gaps, here are the uncertainties, and that's very practically useful in writing the next proposals or directing a research program. Political, public, professional speeches, briefings, those are all ways where you can trace sort of, you know, when somebody draws on a body of research and presents that in a more accessible way. There's also these symbolic uses, and I think that's an interesting one that's much harder to often detect, but it's very important, and that is when people, practitioners, politicians draw on science to make a particular case, and they draw on science because it has authority, it has credibility, it gives weight to. And of course, you know, you all know cases where people on both sides of the political spectrum will draw on maybe a piece of research that you have done, and they pick out very different things and support completely different agendas. Well, that's often the case, right? So it can be drawn on as an on the authority of science to help support or justify a way forward, or also to withdraw and hold back support or resist a particular policy agenda. Of course, the educational uses, and among practitioners that I have interviewed, I see this a lot. They're basically drawing all this science together on their desktop or on their bookshelf or whatever the case may be, both because they want to learn for themselves and educate themselves and let that in some indirect way inform them, not a specific decision, but keeps them thinking and keeps them moving forward in their own work. Maybe it is something that they can bring to the attention of colleagues or superiors, and can be very influential to change the internal workings of a decision-making body through this, if you will, there's a first listener, a first audience that then takes your work and takes it to others in the realm of practice. And that's very, very important internal work that eventually over time might lead to changes in policy or in political stances. Sometimes it is, simply for them to simply learn for themselves and to maybe give a talk based on that. But those are really important uses. And then the final one is actually science as, if you will, a boundary object, or as a means to build a relationship. Here I have something, let's get together and we share, and what you share is maybe not as important as the networking, the trust building, the building of social capital between you and whoever the other person is, the other group is. And that is, I think, we underestimate it, but what we know about decision making, and I will come back to this, is that trust building, that social use, if you will, of the research is one of the most important contextual factors that allows for science to be used in maybe a practical use or in the symbolic use that I just laid out here. I also want to say a few words about what we know about what makes science useful. This draws on research that goes back almost 20 years now. Originally the idea was, and you probably have heard this in one way or another, when science is salient or relevant, specific to a location, specific to a sector, provides high resolution information, it links to the issues that the decision makers care about, when it comes at the right time, right, in the right format, those kinds of things make something much more relevant or salient, if you will. It comes to their attention, and that makes it far more useful than if you're talking about global biodiversity loss or global climate change. Who cares? That's just background, right? But for it to be used in a particular situation, it has to link to a decision maker's concerns. And of course, it has to be credible. Whose expert were involved in providing input? Was there interaction among the experts that led to a more solid, a more complex and full understanding, comprehensive understanding? Was there peer review? Is it transparent how you arrived at a particular conclusion? Those kinds of issues can lead to decision makers or the public to assign credibility to something. They might not know, all the things that you did, and they might not know in detail the methodologies you used and how good and solid that was, but they look at your credentials, they look at your institution, and some of these other aspects. And then of course there is the issue of legitimacy. Have all the different perspectives been heard in arriving at a particular conclusion? Does it account for the concerns of stakeholders, of decision makers, their values, their needs, or is it biased? Those are the things that people pick up very easily, actually, particularly if they themselves have a stake in the outcome. What were the rules and procedures and how people could be involved in maybe an assessment or in a fact-finding procedure? So those are the really important elements of determining whether something is perceived as legitimate. And then of course, if the science doesn't make the life of the decision maker easier, more efficacious, or more easier simply in arriving at a solution, then well, then it's not useful. It is really, if you provide data and information in jargon, in complex models that are just, it takes a PhD, rocket science, or as we sometimes say, to understand it, then that's not helpful. That requires so much time and such a steep learning curve for a decision maker to understand what you are trying to express, that they just say, sorry, I don't have time. Come back when you can tell me in easier terms. And then finally, many things, especially in a dynamic world, have to be updated regularly. Maybe there is some natural rhythm to that. Maybe there is a procedural rhythm, a planning cycle, or something like that. But how easily and how rapidly can the data that you provide, the information you provide, can that be updated? Does it require a whole other round of IPCC assessment? Or is it something that can be fairly easily, and in the procedures of decision making, be replaced? The old data go out and the new ones come in. Those are the kinds of things that make information more useful. Now think about your own work. When you provide a study to the public, do you think about those terms? Do you think about how to make it relevant to people as you communicate about your science? Do you help them understand that this is a credible piece of research? Do you point to the ways in which concerns of multiple sources, perspectives have been considered and assessed? Do you make people's life easier? These are all ways, very practical ways, in which you can think about ways of making the science more useful. And the final one about iterativity, the updating, the easy updating. Just think about how many times we as scientists have an incentive to just do something one time, because that's when we go at for the new thing, for the new idea, and then we move on to the next thing. Even if what you just worked on was super useful to someone, but it isn't useful anymore in 5 years from now, when you have long moved on to a new topic and you're doing new research. Who is going to update that for people? Because it's still useful. It could be useful if the data was current. So that leads me then, to a few ways of maybe categorizing of what is needed from science to be useful. The first one, imagine a practitioner comes to you and says, I know what I want to do, but I don't have the right information. Can you please help me? And you decide, okay, that's worthwhile. I'm going to help. I'm responsive to a very specific need. They know what they need, and you are helping them respond to that, right? So you become, in many ways, you become part of a decision-making process in providing exactly the information that is needed in that process. There's a second way. If you think about decision-making, policy-making in the broader sense, sometimes people might very well know what they want, what policy they want to pursue, what the political move is, if you will, that needs to be done, but people don't understand yet. The public doesn't support it. Maybe people in the legislature don't understand it, or people in agencies don't understand how this is useful. So you might decide, okay, I'm not just providing a piece of information, I'm going to out into the public or whoever needs to hear about it and educate them. I train them in how to use this information. That is being supportive. It's absolutely essential in a political process that there is that building of political will, building of capacity to actually use the information. So a very, very important way in which you can be useful. Now, there's another situation in which a decision maker might come to you and say, here's what we've always done, and it's not working. And the task to you is to maybe find new solutions. So it's much more experimental, right? The decision is not yet set, and you just have to fit into it. It is actually developing new ways of doing things. Maybe no one comes to you. Maybe they're all happy with what they've always done, but you know from your research that that's not leading in the right direction. That's not good ecosystem management. And you approach them with, here is a better idea of how to do this given the changing circumstances in which we live, or given what we know about what's not working. So this, you coming with new ideas about the solutions is another way you can be incredibly useful to decision makers. And then the last category, it's actually the most difficult, but it goes back to what I just said about trustful relationships. Sometimes what is most useful is that you say, no, this doesn't work. This is not good. This is leading to whatever negative consequences, to bad trade-offs or something like that. Oftentimes, you know, this is something that you can only really be when you have built a foundation of trust with a decision maker and they're willing to at least hear that. It also often implies that you then have to come up with a better solution. I have encountered it in my own work sometimes where people say, I can't internally say to my boss that things aren't working. I need you, Mr. or Ms., you know, credible scientist from a credible institution. I need you to say that, because then I have basically the backing to internally do whatever changes I need to, whatever political levers I need to push. So sometimes it's incredibly useful to be that outsider to the decision-making process and be constructively critical of it. So those are just ideas that you know, have come out of some of my own research of talking with practitioners, what they want from you, what they want from science. Now, let's look a little bit at this process of what do we know about doing this interaction between scientists and practitioners more effectively, and what are the lessons from that, and how do these lessons, or how does what we know about that hold up in an ever faster and difficult world? Because at the heart of this conundrum that I see is that we have a growing need for, give me the answer fast, 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 really quickly, because everything is happening more quickly. And because things are changing so quickly in the world, we scientists often say, well, wait. I need more time to understand this better, because we don't know. We're moving into new territory and we can't give you a quick answer. So we need faster answer, but we can't provide faster answer. So what does this mean? Do we just become irrelevant? Or do we go back to, I don't know, you know, the medieval times where decisions were basically made in an uninformed way, or simply too late? Because, you know, by the time you have an answer, the decision point has long passed. That's problematic, right? So we could potentially become, despite everything we know about how to be useful, we could become completely useless, irrelevant. And I think that's a really big problem we haven't thought much about. I'm going to give you just very briefly, with some pointers to the literature, some ways in which we have understood the science policy or science practice interface. For a long time, we thought of it as sort of this linear process, right? Where society pays taxes, provides research funding, and, you know, then we do our pure research, and some of that leads to applied research, and then we do R&D, or, you know, research and development, and look for applications, applied science, and somewhere down the road, there will be a societal benefit. And in many ways, the assumption was that, you know, the best science is when we stay far away from any societal interaction. We stay in our labs or go to our field work, and we do not ever interact with anybody. Research is a good thing. It is value-free. It's totally objective, and let them do their thing, and then eventually we will benefit from it. And that essentially, you know, was just the fact that we create knowledge was sort of seen as the greatest and highest good, the highest benefit from science. But it really constructed a world where science was the holder and the producer of knowledge, and everyone else was essentially a non-knowledgeable sphere of society, which of course is very problematic. And somewhere the hope was also that this transmission, this transfusion of scientific insight would happen somehow automatically, maybe via the media or some dedicated translators, some consultants or whatever. But essentially, as a scientist, I wouldn't have to deal with that. Somebody else does the communication, leave me alone. That was for a long time how science worked, and some still works. Well, I guess the world recognized that that's not how it is. And what you see here is something that's become quite well known in the study of how science works in society, known as Pasteur's Quadrant. What you see here is basically a matrix where, on the one hand, you look at the relevance for producing generalizable knowledge, and on the other hand, producing knowledge that is relevant for immediate application. And in other words, where you consider the use or you don't. And so that produces 4 pretty distinct types of science that have been named after these different scientists, and I'll talk you through it in particular. In this lower corner, where there is no relevance to anything practical, immediate right now, and you are not trying to produce theoretical, generalizable knowledge, you might call that tinkering. And there's no scientist that likes to be associated with it, so there is no science name associated with this particular quadrant. In the upper left corner here is where you really are interested in generalizable knowledge, but you're not considering to what end is that going to be used. And Niels Bohr is sort of the poster child for this particular type of pure basic research. You do not worry about what will happen. There will be eventually maybe some uses, some benefits, as we all know what came from Bohr's research, but when he conducted his work, he didn't think about application, right? Then there's Edison, who is really interested in solving one immediate problem. How do I get this bulb to glow, right? That's how we got the light bulb. That's pure applied research. He was not interested in producing some grand theory of how electricity works. He simply wanted to get that little wire to glow. And then there's Pasteur. And the idea there is that there's absolutely an interest in providing or generating generalizable knowledge, and it has to be of use at the same time. So he called that use-inspired basic research. You basically interact with societal decision makers to understand what are their concerns, what are their interests, and then you pursue the questions, whatever, and you look, maybe that's already been solved. Well, then it goes into Edison's field and, you're no longer needed. But maybe some of the practical questions that decision makers have open up entirely new areas of basic research that haven't been answered. And that's a really interesting one. Certainly in the on the right-hand side with Edison and Pasteur, that's the area where we actually need to interact with societal actors. And in the spirit of Edison in particular, in the spirit of Pasteur, given how many new and complex and currently unknown or uncertain problems, climate change and other global problems open up, we really need to think much harder about how should science work with society, which is why Gibbons and Lubchenco and Novotny and others have called for a new social contract for science. Not the one where you just give them money and they go away and you leave them alone. But no, there's an accountability that we as scientists have to society. And what does that mean for us? Well, and that's where the idea of mode 2 or transdisciplinarity, engaged science, collaborative science, action-oriented research comes from. The notions of co-designing and co-producing knowledge. And it's fundamentally different. Look at some of these assumptions. Research is always influenced by values, compared to what I said to you earlier, the assumption that research is completely value-free. Not true. It is always, I emphasize this, influenced by values. As much as you think you do objective research, you do your very best to do it in a very systematic and rigorous way, absolutely, you can do rigorous research, but you're still influenced by values. Science becomes more useful and use becomes more likely when you interact with users, and decisions are actually better when they are informed by scientific knowledge. These are all rather different ideas compared to in mode 1, what I showed you earlier. It's also a recognition that there are actually multiple knowledge systems and spheres that exist at the same time and that interact. And that interaction, that boundary between different ways of knowing needs to be actively managed. So how do we do that? What do we know about this? Well, there are different degrees of linking the science practice interface. One is where you basically, it's called linking, according to Klenk and colleagues who sort of categorize the different degrees of interaction, where you simply say, okay, I do my research and then I want it to go very specifically to certain users. And you basically make sure you communicate, you write a press release, or you simply get the information in particular usable, understandable formats to the people you think need to hear about it. It's an important way. It's not the only way. The second one, matchmaking, is where you sit down before you ever start your research. You sit down, connect with users, and frame the research questions together. Then you go away, do your research, come back and engage those stakeholders again in interpreting what does it mean what I just found. That requires a very different management, if you will. It requires occasional, putting on workshops or putting together engagement opportunities on Zoom or in person where people can meet. In the third category, you actually collaborate in that users and producers of knowledge work together to identify research questions, also shape how you do the research. Maybe they help you in data collection or analysis, and in deciding and even developing what products should come out of it. It's a much higher degree, right? In the matchmaking, you just had a couple of points of interaction. Now you're basically working with people all along the way, but you're still very much focused on sort of following rigorous scientific procedure in the way that you know best. For that, you might need one or individual or an entire organization that might help you manage that interaction, because you're really best trained to be a researcher, and still that interaction needs to be well facilitated. The final level, maybe the highest or deepest levels of interaction, is what they in this instance call co-production, where you actually empower and build capacity within your stakeholders to generate and evaluate knowledge, their own and yours. And then you integrate the different knowledges to produce something that you yourself could never do by yourself. And for that, it typically helps because it's not something you do very easily and quickly. It helps to set up institutions to basically develop that. Interesting, I just want to show you this as a little snapshot. This was a review of abstracts to one conference, American Geophysical Union annual meetings, where they looked at, what in the abstracts suggests that people are doing any of this type of interaction. And you see over the last, I don't know, this is 15 years, but if we continued this, I'm sure the trend would continue, that there is more and more emphasis of working together, co-producing, co-creating, co-developing, co-designing, that highest level, but it's still fairly, limited. Generating useful information where you at least have to have one or two, or possibly, one or two points of interaction, that also is increasing. And the biggest growth really has been at least in partnering, in helping, maybe get information from them, gather data, really helping to shape the study, the research. I find that really significant. This shift, the American Geophysical Union is the bastion of physical science, of natural physical sciences. It is not, you know, some, oh, I don't know what I want to call it, but it's an area where this kind of research has maybe found the greatest resistance. Let me put it this way. And over time, you see still how much that is growing. And I'm sure the same is true in ecology. In fact, I know of studies that have looked at similar trends in ecology. It is certainly true in the social sciences and in many of the interdisciplinary fields that you work on. Now, here comes the thing. What do we know about when this works well, this relationship? Well, we know that science is more likely to be considered in decision-making, in practice, when the decision makers think it is credible, relevant, and legitimate, as I just mentioned to you. And that is more likely if the scientific information is actually more usable. I already mentioned that, right? There is a shared understanding of the problem and the decision context so that you can tailor the information for the decision. It comes at the right time in a format that is dependable, reliable. It makes life easier, and it actually makes better decisions. Under those circumstances, it's more usable. Now, what do we know about the likelihood of actual use? Well, the more often you work with people, the users, the more you help them build the necessary knowledge and skills, and the lower their risks are, or the greater the benefits they understand from using it, and the more they trust you, the more likely they are to use the information. What that means, this trust building, is you need to spend time, right? And that's that thing that we don't have. It is when you build trust, when the relationship is mutual, when you're intentional about it. There is a perception that you are competent. You think of the partner that you're working with as a competent person, not just you hold all the knowledge and they don't, but that you're both competent, credible experts in your respective areas. If you promise something and you follow through, and you simply spend time with this person. This is the issue, right? We need time to build trust. We need all these other forms of interaction, frequent interactions, for people to actually use the information, be more likely to use it, and then that information becomes more usable and people see it as relevant and legitimate, and then they might actually use it. Now, if you want to go fast, go alone. If you want to go far, go together. That's an African proverb, right? And in many ways, I feel like it speaks directly to the problem we're now facing. Climate change and other changes demand that we go faster and faster. And so you might think, well, let me just do it by myself. Well, if you want to actually get somewhere with your science, you have to do it together. So that raises the question, how can we speed up what you do, production of usable science? How can we speed up decision making? And how do we speed up the interaction between the two, the linking of the two? There are many things we can do. Better monitoring for rapid detection of problems, rapid assessment methodologies, using big data, that's all coming on, right? Having the partnerships and collaborations already in place and nurture them over time so you don't have to like rebuild them every single time in a new way. It takes time initially, but you know, it saves you time later if you actually maintain it over time. If you have scientists who are permanently, or at least for certain time periods, embedded in decision-making institutions, you know what they need, you understand their life better. It makes you a much better scientist in actually asking the right questions. And if you help basically train and build capacity, both within the university environment, so that people know how to do this interaction well. You train yourself, you learn yourself how to do this well, and you maybe even help train others. On the decision-making side, I think a lot could be done too. We know it's so bureaucratic, right? Red tape. How can that be reduced? Is it necessary? How can that be done? That takes for years to make those kinds of changes. But so often we know there's duplication and redundancy, and is there ways we can streamline decision-making that would save so much time, right? For example, integrated permitting, or removing funding barriers, having joint funding for certain problems, having interactions across agencies, across sectors, across scales of governance. Again, those things all take initial time investment, but I think over time, if they are maintained and institutionalized, can save a lot of time and certainly a lot of working at cross purposes. The same true as it is on the other side, on the science side, capacity building within the agencies. I do that a lot right now in my own work, training people in NGOs, in government agencies on matters of resilience or adaptation or transformation. It's really important to remember they don't have time to read all the science that you are producing. And so, you know, how should they know? Well, they basically need training, and it's absolutely important to do that. And maybe even embed, have scientists embedded there, or, you know, go and embed among scientists as an agency person, having a year or a half a year of time of going to a scientific institution to catch up with where the state of the science is. And then there are ways to maybe even speed up in the middle, that interaction. Can we have standing institutions, we call them boundary institutions, that help with that interaction? So you can do what you do best, they can do what they do best, but there's someone there who helps basically do that bridge building and help you be the best you can be for each other, even if you don't have to do all the relationship building yourself. Facilitating more frequent and more useful interactions. Oh, how many meetings have you been in that have been complete wastes of time because they were not well prepared, because people don't know how to, you know, facilitate that well? Well, there are experts in that. Why not use them? Why not have those kinds of expertise even embedded as a part of the scientific institution or as part of the decision-making institution? And then those people who play that center or that bridging role, that boundary role, have really important work to do, helping to set priorities, actively help to remove the barriers, whether they're legal or financial, political, helping with some of that training that we talked about, adding value to science by, you know, really doing the legwork to say, well, this is the best knowledge, the best tool, the best information. I always like this example when people talk about so-called nature-based or green infrastructure. In the US, someone did a review. There are 16,000 tools for green infrastructure. How is a practitioner supposed to know anything? Which one to use? It's completely useless, right? And then also evaluation. I do a lot of evaluation work, and I have found evaluation of that science practice interaction to be the best kept secret about how to make this better. It's really phenomenally useful to look at how could we work together more effectively. So comes back to the question then, what if we need to go far and fast? How do we then do all these things? Well, I am thinking that there might be a metaphor that you could relate to of how we could organize ourselves in a way that allows us to go far and fast together. And that metaphor is one you're familiar with. Migrating birds, how do they fly? They basically go in an alignment that allows them to go much farther and much faster together than if any one of them flew by themselves over the same distance. What does that mean? Well, maybe at the front end of decision making, we need someone who helps the decision maker, essentially like a coach, to make a decision. And oftentimes they need to have access to people who have generalist knowledge, you know, have a broad view of what is out there, who is doing what, so that we can quickly draw on that kind of big picture overview understanding to help the decision maker. It also requires very skilled communicators, and maybe even some of those tinkerers, some of those people who are trying and willing to try things, experiment, whether or not it is, you know, for broad use in general. It's one player in a larger field, because the next set of people then is we need people who evaluate that. What worked? What didn't work? What can we learn from that? We need to have people who know about good decision making. We have to have these boundary organizations that help manage us, people who are good at synthesizing across a broad range of research, because in most instances, decision makers don't need just one tiny, narrow little piece of information. They need to have a big picture. They need to understand all the different factors that weigh in, and that requires synthesis of a broad range of research. And behind them are the people who do research that is inspired by the needs of decision makers. So absolutely, we need to have those researchers behind them, and that's not all of it yet, right? Can we draw on citizen science more effectively to gather a broader sense of, or get faster at the data, have a broader sense of it? We need applied researchers who solve very concrete problems with the existing knowledge. Big data science is absolutely needed because it allows us to tap into this explosion of publications and knowledge that is out there, but that no one, if we're really honest, no one has time anymore to read all that, right? Yes, and we need innovation research, pure research that looks at, both at the social, technological, governmental, methodological, in the physical sciences. We absolutely need to have new ideas to generate new solutions to existing and growing problems. And because oftentimes it's in places that don't have access to all the science, we need people who advocate to make that science open. Science that is not accessible is essentially useless science, at least from a point of view of being accessible to society. And then, of course, yes, the fundamental researchers, science education, modern science education, and by that I mean in mode 2 education, not the siloed, disciplinary, narrow kind of pure research only. And we need, people who advocate for science. As you know very well, in the current public sphere, there's a lot of debate. Many people don't believe in science anymore. I think we have lost somewhere the battle of science being relevant in many ways and credible, and with a large part of the population. So we need to have people who are dedicated to actually making science a respectable thing again, and funders who see this broad picture and who would be willing to not just fund one project at a time, one piece at a time, but who are willing to support the flock, right? The entire flock, not just one piece of it. So what that means is, I think we're actually in a good place in that we have many geese already, and they're ready to align themselves, but they're not yet there. They're not yet aligned in the most effective and efficient way. So I think there's much we can do to help them organize and get connected. There's also much we can do to build their capacity to be better, working together more effectively. So helping them align and helping to work together in this, with that picture of we're working together toward a societal end. It is not well supported at this moment. You know how fragmented it is. There's efforts going on in the funding community to come together more effectively, connect North and South science, but also across the disciplines and the big kingdoms of science. And there's unfortunately still far too many fences and problems, I guess, in our own universities and institutions to working together. And I think it needs advocates and leaders internally to overcome some of those. So I guess maybe the upshot from that is, if we do not want to become irrelevant, and if we're not supposed to go to sort of pre-Enlightenment era again, in light of this fast and rapidly changing world, I think there is so much good and useful work we can all do. Not just research, but helping the whole enterprise become aligned. And personally, I find, and I'm happy to discuss this with you and would love to hear where you are with this, but if we are not finding our way into our position in that V, in that flock, I think it's almost like modern day heresy. we're simply refusing to be useful. And I don't think we have that luxury anymore. So I think there is much to be done to be more strategically aligned in the flock. And let me quickly check on the time, how we're doing. Should we maybe stop here and skip the communication, just have time for conversation? What do you think?